When you think about modern cars, it's amazing how much lighter and stronger they feel, how efficient they've become. We tend to focus on the outside, right? The design, the engine, maybe. But so much innovation is actually hidden in the materials, the skeleton of the car. And today, that's exactly what we're diving into, the global automotive alloy market.
Yeah, and our mission here is really to unpack the latest research on this market because honestly, it's fundamental. If you want to understand where transportation is headed, sustainability goals, the rise of EVs, all of that,
Yeah.
well, these materials are key. They're not just parts. They're enabling the future.
And it's foundational is the right word. The scale is just huge. Our sources put the market at what, $97.29 billion back in 2021, projected to clear $124 billion by 2025. And then the really big jump, expected to hit almost $204 billion by 2033.
Hmm.
I mean, that's basically doubling in what, just over a decade. And that growth rate, the CAGR, is over 6.3% between 2025 and 2033. That signals some pretty serious expansion ahead.
Absolutely. And it's fascinating when you dig into why it's growing so fast. It really boils down to this global push, this demand for vehicles that are lighter, stronger, and crucially more energy efficient. These advanced alloys, they're not just nice to haves, they're completely essential now.
Essential how? Like for both electric and traditional cars?
Exactly. Think about EVs. Weight is everything for range,
Yeah.
right? Lighter alloys mean more miles per charge. As
Right.
simple as that. But they're just as vital for your regular internal combustion engine vehicles, the ICE cars, helping them shed pounds to meet those really tough emissions and fuel economy targets. So it benefits the whole industry.
Okay, so when we say advanced alloys, what are we talking about specifically? The sources mention aluminum, magnesium, obviously later metals, and then specialty steels. That's
Yeah.
interesting. What makes steel special in this context? Is it like a different recipe or something?
That's a great question. Yeah, specialty steels isn't just one thing. It's a whole category. We're talking about things like advanced high-strength steels, AHSS, or even ultra-high-strength steels like boron steel. What makes them special is, well, partly their composition, tiny amounts of other elements, complex structures inside the metal, but it's also about sophisticated processing, things like hot stamping.
Hot stamping.
Yeah, it lets them make parts that are incredibly thin and light, but still meet really high safety standards in a crash. Stuff conventional steel just can't do. It's about tailoring the material for very specific jobs in the car's structure.
Right, so it's not just picking something off the shelf that's lighter. It's really deep material science driving this. And that explains those huge growth numbers, nearly doubling between 2021 and 2033. It's clearly not just small tweaks.
No, not at all. And if you connect the dots, this growth isn't just about building more cars. It's tightly linked to these really big transformative trends. Global sustainability goals, the massive shift towards electric vehicles. These materials are right at the heart of making those things possible, enabling cars to go further, use less energy.
Lowering emissions.
Exactly, helping achieve those environmental targets. Without these material advances, honestly, a lot of those goals would be much harder, maybe impossible to reach.
Okay, those global numbers are impressive, but where is this growth actually concentrated? Is it everywhere, or are there specific hotspots? The regional breakdown must be pretty revealing.
Oh, absolutely. Regionally, Asia-Pacific is, well, it's the giant right now. In terms of sheer volume, it went from nearly $39 billion in 2021, and it's projected to hit over $84 billion by 2033.
Wow, why so dominant?
Two main things. Just a massive increase in car production overall, plus a really rapid move towards electrification in many countries there. You've got China, obviously huge, projected over $24 billion. Japan, also significant, over $16 billion.
But I noticed some interesting details in the numbers there. China and Japan lead in size, okay, but look at the growth rates elsewhere. India, for instance, is set to hit nearly $13 billion with a CAGR over 7.5%. That's strong.
Very strong.
And then this category, the rest of APAC, so everywhere else in the region, their CGR is even higher, like 8.6%, heading towards $11 billion.
That's right. And that really tells the story, doesn't it? It shows widespread development, rising demand across many, many countries in that region, not just the biggest players.
Okay, let's shift gears. What about North America?
North America also shows really significant expansion, doubling pretty much, from $28 billion in 2021 to over $56 billion projected for 2033. The U.S. is the dominant force there, no surprise, expected to reach over $44 billion.
But again, look at the KGRs. The U.S. is huge, but Canada actually has the highest growth rate in the region, over 7%.
Hmm.
reaching $6.5 billion.
Yep, that's a fascinating detail.
And Mexico is also substantial, over $5 billion. So, similar story, growth isn't just in the biggest market.
Precisely. Then there's Europe. Steady progress there, expanding from about $18 billion in 2021 to over $36 billion by 2033. Germany, France, the UK, they're the leaders, all projected around the $4.5 to $5 billion mark, roughly.
And let me guess, the rest of Europe has a strong CAGR too.
You got it.
Yeah.
Set to reach over $9 billion with a CAGR above 7.2%. Again, showing that broader adoption across the continent.
Okay, what about other regions? South America?
South America, definitely seeing emerging momentum.
Yeah.
Is going from $6.5 billion to nearly $15 billion. Brazil leads the pack there, projected at over $4.5 billion.
Not just Brazil, right? Argentina's CAGR is impressive, nearly 8%. And the rest of South America isn't far behind.
Exactly. It points to, increasing sophistication in automotive manufacturing across the continent.
Middle East.
More modest growth there, but still steady, expanding from $3.5 billion to over $6.3 billion by 2033. Saudi Arabia and the UAE are the main players.
Okay, so we've covered most of the globe. Seems like strong growth almost everywhere. But are there any, real standouts in terms of acceleration?
Well, you save the most, perhaps surprising region for last, Africa.
Africa, really?
Yes. The growth there is expected to be phenomenal. It's projected to nearly triple, from just under $2 billion in 2021 to almost $5.8 billion by 2033.
Triple. Wow. What does that mean in terms of CAGR?
It means Africa has the highest regional CAGR by far, an astounding 10.1%, basically. South Africa and Nigeria are significant contributors, but listen to this.
Okay.
The rest of Africa, all the other nations combined, is projected to hit $2.6 billion with a CAGR of over 10.5%, the highest anywhere.
That's incredible. So Africa is genuinely the fastest growing region for automotive alloys. That really shifts the perspective, doesn't it? It's like watching a new industrial powerhouse emerge in this specific sector. An unsung growth story, definitely.
It really is. So if you pull all these regional threads together, what you see is a global industry that's, well, it's transforming deeply. This huge demand for advanced alloys, it's not just about making cars slightly better. It's about a fundamental shift, a shift in how we approach transportation, energy use, environmental responsibility. These materials are enabling that shift.
Right. And that brings it back to you, the listener, because these changes, these material innovations, they directly affect the vehicles available to you. They mean better performance, maybe longer range in your next EV, or better fuel economy in a gasoline car, lower emissions, better safety through stronger structures. It's all tied into making the whole industry more sustainable. You're part of that ecosystem. So to wrap up, the global automotive alloy market, maybe not something you think about every day, but it's this quiet giant. It's expanding rapidly, and it's absolutely crucial for the future of how we get around, whether that's in EVs or still in advanced ICE vehicles.
Absolutely. And maybe a final thought to leave you with. As you think about technology and sustainability, consider how often the really big changes rely on these unseen foundations. The flashy end product gets the attention, but it's the underlying material science that makes it possible. It makes you wonder, doesn't it? What other hidden material innovations might be quietly reshaping our world right now in ways we haven't even fully realized yet?
Welcome back to another deep dive. Today we're getting into something pretty fundamental to how cars are made and perform the automotive alloys market.
Yeah, it sounds a bit technical, but it's crucial stuff.
Absolutely. Our mission today is really to unpack how these materials are helping automakers balance performance, cost, and sustainability. It's a tricky act.
Especially now with everything changing so fast.
Exactly. We're using the latest market research to see, what's pushing this market forward, what roadblocks are popping up, and what kind of cool trends are on the horizon.
Sounds good. Where should we start?
Well, let's dive right in. What's the biggest engine, so to speak, driving this market right now?
Okay, well, the most immediate thing I'd say is the huge push for lightweight vehicles. Automakers everywhere are under pressure to hit tougher emission standards. Those Kyoto targets in Europe, North America, Asia.
Right, the fuel efficiency targets.
Precisely. And it's not just about tweaking engines anymore. They need fundamental changes. So materials like aluminum, magnesium, even titanium, they're becoming the go-to options.
Okay, so lightweighting for efficiency makes sense. But what about electric vehicles? Their growth is explosive. How does that specifically impact alloys?
Oh, hugely. That's a massive driver. EVs and hybrids, well, they desperately need strong but light alloys. Why? To offset those incredibly heavy battery system.
Ah, okay, because more weight means less range, right? Or you need an even bigger, heavier battery. It's a cycle.
Exactly. So you see these alloys now in chassis parts, battery housings, motor components, basically enabling the kind of EV designs we're starting to see now. Couldn't do it with just steel.
And it loops back to safety, too, doesn't it? Lighter doesn't mean less safe here.
Not at all. In
Right.
fact, using alloys with high strength-to-weight ratios means you can actually design better crash structures.
Yeah.
So it helps meet those tough global safety standards for crashworthiness while also hitting the environmental targets. It's a win-win, really.
If you can manage the challenges, I suppose. Which brings us to the hurdles. It can't all be straightforward. What's the big one?
Cost. Definitely cost. High-performance alloys, we're talking certain titanium grades or advanced aluminum.
Yeah.
They're significantly more expensive than good old steel.
Like, how much more expensive are we talking? Ballpark.
Well, it varies a lot, but think maybe 5 times the cost per pound for some aluminum compared to steel, and titanium can be even higher than that.
Wow. Okay, so that naturally limits where they get used.
Pretty much. It tends to restrict them, more to premium vehicles for now. Makes it tough to justify on a mass market car from a profitability standpoint.
And I guess it's not just buying the metal that's expensive. Making things out of it must be trickier, too.
You got it. Manufacturing complexity is another big one. These aren't like steel. They often need specialized welding, different casting methods, really specific heat treatments.
So you can't just drop them into an existing production line easily.
Nope. Retrofitting lines built for steel is expensive and, frankly, operationally a massive headache. Companies really have to rethink how they build cars.
And then there's getting the raw materials in the first place. We hear a lot about supply chain risks globally. How does that play in?
Oh, it's a critical vulnerability. Absolutely. Getting hold of things like magnesium, nickel, some rare earths. The supply can be really volatile. It's tied up in geopolitics, trade issues.
So a sudden event somewhere could spike prices or even cause shortages.
Exactly. We've seen it happen. It forces car makers to scramble, find alternatives, or just swallow huge cost increases. It adds, let's say, another layer of risk to choosing materials.
Okay, so cost, complexity, supply risks. Quite a few challenges. How is the industry pushing past these? What trends are emerging?
One really interesting trend is multi-material design. Automakers aren't just picking one wonder material anymore. They're blending, using the right material in the right place.
So mixing alloys with other things.
Yeah, mixing alloys with composites, with advanced polymers, creating these hybrid structures that are strong, light, and maybe a bit more cost-effective overall. Think ultra-high-strength steel, where you need maximum crash protection, aluminum for body panels, maybe some composites elsewhere. It's very strategic.
And sustainability must be a bigger focus now, too.
Definitely. Huge push towards recyclable alloys and developing closed-loop manufacturing, basically recycling scrap right back into production.
Which helps with the environment and maybe eases some of that reliance on new raw materials.
Precisely. It tackles both issues. Smart business, really.
And what about pure technology? Is it changing the alloys themselves?
Oh, absolutely. We're seeing cutting-edge stuff like additive manufacturing, 3D printing for metals, and advanced casting techniques like high-pressure die casting.
Yeah.
These let engineers create totally new alloy grades, materials with better strength, better resistance to corrosion, better performance at high temperatures.
And more design freedom, too, I imagine.
Exactly. You can make complex shapes that were impossible before.
Yeah.
It's really about engineering the material itself for the specific job it needs to do in the car.
So when you pull it all together, these alloys, they aren't just passive materials being bolted onto a car.
Not at all.
They're more like strategic enablers. They're fundamental to how the industry meets all these competing demands.
That's a great way to put it. They are absolutely foundational. Foundational to this whole shift towards vehicles that are cleaner, safer, and, smarter too. It really makes you think next time you see a new car, but all the unseen engineering, especially in the materials, that makes it all possible. They're often the hidden heroes defining what that vehicle can actually achieve.